Welcome to another edition of DraftScience. Yeah, whatever. Tired story. Anyway, still with the power failure crap. So, yes. So, nice 7 days. We had power one day. Really fun. But it should be on today. So, see how it goes. Alright, so the persistent person who's responsible for this animated whatever it is. So we'll look at the animation for a moment. Alright, so the story on this apparently is he just drew these as like in paint or something, and there's not an automatic program that puts this math together and moves these things, so it's just an animation he made by putting slides together of his own drawing or something, and not something more sophisticated than that. He should be able to explain exactly how he calculated these distances and times, yet he hasn't provided that information at all, and he didn't even know what speed he scaled this to. So he can't even give us a specific, like, is it 40% the speed of light? Is it 50? Is it 38? What exactly percentage of the scale of reality is it? So this, I'll point out 2 points that he just keeps ignoring. Yeah, that's what I'll do. And this other person, the Minty Mints, keeps saying, I'm still interested in the bet. Well, I'm just trying to save you money, because if the bet is there's no math behind those drawings, then you're already really in huge trouble. That it isn't an accurate model or scale model or representation of what happens in reality, and I'll automatically win. Now, I'm going to win anyway, because the argument's going to be, is there any evidence that at the time Michelson and Morley proposed this interferometer for use as a way of detecting a length change in the arms with movement? The argument is that's decisively provably not possible by the physics that existed at the time Michelson and Morley proposed it. And the only way you can do it is with some kind of gimmick physics that isn't even really rationally in general relativity. It doesn't work. So just trying to save you some trouble. But anyway, I mean, if the author of the video, like I said, he already produced a copy where he seemed to concede a point in the sense that he actually drew the right length. And so, but he's apparently denying that now. Okay, so his response, I pointed out, so he has a new one, and he updated it. And I said, same crap. Photons move 2 directions at once. No accounting for the angle change at the mirror. No accounting for the fact that at the speed of light, the vertical photon can't reach the mirror at that location. And he says, yeah, it moves 2 directions at once. Well, how does it do that? It's not a baseball. It can't go at extra fast or extra slow. But it moves vertically slower. It's not allowed to move slower, quote unquote. You're supposed to be doing a proportional distance to speed thing, so one of the things has to be consistent. Either the distance has to be consistent or the speed is consistent, but you can't make neither consistent. That's called cheating. So you can't change its speed conveniently without affecting its distance. Alright. Anyway, no accounting for the fact that the speed of light, the vertical photon can't reach the mirror at the location. I said, okay. Let's see. Okay, yeah, move 2 directions once, but it moves vertically slower. Yeah. So its total speed is still c. How could its total speed, if it's moving slower, how could its total speed be something consistent, a constant? It can't be. It just doesn't make any sense. It moves vertically slower, yet it's still not slower because it's still moving c. That doesn't make any sense. And it clearly reaches the mirror. Your point? My point is, this is nonsense. And you know, so point number one, as pointed out before with no response. At the time Michelson-Morley proposed this experiment to the drawing board, there was no relativity theory. So there was, I think, a common understanding that when we looked at, say, the sun, we were seeing the sun, if it had a position, at the position it was at. Well, see, since we're doing the spinning, that one's a bad example. So let's just use Venus. We were seeing Venus where it would be, okay, where it was, not where it is. And if we look at Jupiter, you see where Jupiter was. You don't see where Jupiter currently is. So if we were to shoot a satellite or something, we predict where Jupiter will be, because we don't see it where it actually is. We understand that it's in a different position, and that's how we do our predicting. But if we're going to shoot an instantaneous beam to Jupiter, we would know not to aim where we see it, where the light's coming from, because we know that light isn't really the light that currently is coming off of Jupiter, and that Jupiter's in a different position. And we know that Jupiter's light doesn't move with Jupiter. Alright. For example, so there was no expectation that light moves forward, that it hooks to the future. We look at stars, we kind of understand we're seeing something where something was, not where something actually is now. So that's a simple argument. 1A. Do you understand that's the physical reality that most physicists, the vast majority of physicists, 1A. A response is expected to these, or else you can just go to hell. Okay, you either answer some of my questions or just fuck off. So 1A is, do you think that light bends to the future? Is there any evidence at the time of Michelson-Morley that anywhere that we are seeing stars where they actually are now, not where they were? That their movement doesn't allow them to cast their light in a new direction? Alright, do you believe in that or don't you? And if you understand that light moves in a straight line from emitters, then you'll understand the point I made previously, where when the perpendicular leg in the Michelson-Morley experiment, okay, when that leg shoots, when photons are going up that leg, alright, they go in a straight line. That is, they leave the emitter straight. Each time the emitter's in a new position and releases a photon, that photon goes straight and it keeps traveling, and unfortunately by the time it gets here, the mirror has moved maybe here. So it misses the mirror and shoots into space. So that's the big one of point number one. Alright, do you understand that at the time of the Michelson-Morley experiment, this was the common understanding of how photons work? There was no understanding that they automatically go this way by some magic. Alright, by Einstein magic. That they automatically point in the direction of their velocity. That they acquire two momentums. And they do this part for free. That you don't have to account for it at taking any time. So this portion of their movement doesn't take any extra time. They don't actually have to travel this longer path. They just go up and over for free. Up and over for free. Do you understand how that isn't the truth? Okay, and point number two is related to the distance of this. So when he drew his argument defending his GIF, the video argument, he essentially drew the photon not doing the staircase thing, okay, where you go this way for free, but he actually drew it as a straight line to the mirror and then back. Alright, well, let's understand, if it is a straight line, then it doesn't bounce back this way, right? It's angle in, angle out. So do you understand that? Okay, that you're not going to come back straight. Alright, and that this distance, requires you to do some math. Did you do this simple Pythagorean math? Did you take the square of this and the square of that and to get the square of this, and then take the square root of that number to acquire the length of this distance? Because the length of this distance decides how fast your little ball moves. So that little ball moves up based on the length of this line. My argument is he's nowhere near this accurate representation, and that neither is he hitting the mirror in the right position, alright, halfway between the maximum distance the other ball travels. So as the other ball travels this way, it has a maximum distance. It's halfway to that maximum distance is probably where the mirror is going to be, and this will never hit the beam splitter as it comes down. So if you hit this mirror, you'll miss the beam splitter in all likelihood. But anyway, well, no, you'll seems halfway. The reflector is the emitter, so it's moving at the same speed. So halfway would be correct, and then halfway again. Yes. All right. So it's equally halfway. But anyway, the real point is this determines this line, the square root of this square, all right, and this line determines the actual compensation speed. So he just responds with, I made it go slower. He doesn't respond with any specifics about, well, where's your math? So I'll ask for math this time. Where's your math explaining how you calculated how long this line is and how much to change the speed? So I want that number. I want the math you used to determine this length of how long it takes to get here and then to here. Because I'd say quite obviously the little bit of added time you've given to this up and down. So the difference is this is the motion in his drawing. In this thing standing still, this is the only distance you have to travel, is this up and down, where in the reality this is the line you're traveling. So it's the difference between this line and this line. And I think any idiot can see that two of these and two of these are not going to be anywhere near equal. So so let's just leave number 2 that simple. Did you use Pythagorean math to assess what this line is and double it appropriately to figure out how much to compensate the speed by? Because this is your actual distance. So your math must have accounted for the fact that instead of 2 of these distances, you have to use 2 of these distances and calculate how long it would take something moving at the speed of light to travel those distances. And as I've pointed out before, you're going to get into some trouble because the distance is likely going to come up short to hit the mirror. But I won't get into that argument in this argument. So let's just deal with how did you determine how much to compensate the speed by? And I'd say it's nowhere near the percentage necessary to equal this. And if you actually make it go that slower, the 2 balls, one going this way, alright, and hitting the beam splitter again, and the one going this way and back will be exactly the same. They'll both hit here at the same time. So if you use this real distance and this real distance, these 2 lines will be exactly the same length. So when you add this up and you add this up, these 2 are equal if you do the math correctly. Alright, that's good enough. You'll just keep it simple, stupid. So number 1, at the time of Michelson-Morley, was there any reason to believe light moved forward? And number 2, if we know that it's not moving, if we're going to accept that it can move forward, it does move forward all by itself, and we're going to accept that is the explanation for why this doesn't happen, and somehow it doesn't work with any other light produced in the real world, that is, all the other moving things aren't able to do this automatic shoot your light ahead thing. But let's accept that it exists, even though it's wrong. You can't do this staircase thing. You got to do the real diagonal line. And did you account for the rather large proportional difference in distance traveled? Okay. Probably enough on this subject. So you either answer these questions or there's no point. So I'm asking you also, Mr. Guy who wants to have the wager, do you understand these 2 points? And so if you want to defend either one, that Michelson-Morley somehow magically knew it does go forward, which means they invented relativity before Einstein. So let's understand the consequences of number 1. If you think Michelson-Morley, the reason why they didn't think this was going to happen is because they knew light goes forward. Well, if you think they did know that, then 15 or 20 years before Einstein invented the theory of relativity, Michelson-Morley invented it. Because that's relativity. Newsflash. So, see if I get any answers from these buggers.